So what I'm actually going to tell is a little story. So it's a story which I sort of try to encapture in that picture, which I gather is actually a real picture, which is sort of hard to believe. But that story is really simple. So these people have a short-term goal, which is putting a little white ball in a hole, and they're ignoring the long term, which is a real risk, and it's coming down on them really quickly. And what they need to do is connect those couple of things and come up with an action plan. And at the moment, you don't see an action plan there. And I just find this picture extraordinary. Yeah, who would be playing golf when there's a raging fire just in the background? And that's the sort of thing we have to deal with. How do you actually get action when you've actually got clear and present danger?
Go ahead, please.
So the first picture, which I'm sure many of you have seen something like this before, is that global temperatures keep on going up. And we know this has been reported in many places. But the really important thing I think about this is if you actually look at the variability of temperatures, there's always going to be cold years and hot years. But if you actually look at the recent part of this record, which is up on the right-hand side, is that a cold year now, globally, is way hotter than the hottest years when my grandparents were born. So the envelope of variation, which used to exist, we've now exceeded that. So the variability we're faced with now at a global scale far sits outside the variability we had to deal with in the past. And this is true also at a regional level, but not necessarily true at a local level where there's a lot more noise in the signal. And so the importance there is that, yes, there is a trend, but there's also variability, and it's the relativities of those that you need to think about. And when we start to think about that, is that it's about what are the projections for variability in the future. So this is a meta-analysis that I was part of in the last IPCC report, which looked at variability of crop yields going out into the future. So this is pulling together all the different studies on crop yield that we could find. And if you look at the left-hand side of that, 2020, 2040, there's relatively small variability. But as you go out towards the end of the century, that variability increases massively. So climate change is likely to actually result in really significant changes in variability. So the risk associated with, in this case, food production, but equally with transport systems or communication systems or energy systems, is likely to increase. And so our ability to manage that variability by using things like seasonal climate forecasts is only likely to increase over the next decades. And it's not just the fact that the variability is increasing or likely to increase, but we've also got a lot more assets. So the asset base and the value of that asset base is growing. So there's more money on the table. There's also, in many cases, increased exposure of those assets. So they're put in places which are more vulnerable. So putting buildings next to rivers or putting buildings next to coastlines where sea level is likely to impact on them. We're also seeing increased connectivity. So when there is an event, the ramifications are not just felt locally, but felt globally. And because of that, the importance of managing risk and managing climate variability is also increased. And maybe there's going to be increased frequency, degree and location, changes in location of extreme climate events due to climate change. So what we're already seeing in the record is that cyclones or typhoons or hurricanes are stretching towards the poles. So in the northern hemisphere, they're stretching out towards the sort of the Arctic, and in the southern hemisphere, they're heading towards the Antarctic. So the area that can be affected by extreme events is changing. So places that didn't used to get affected by hurricanes, typhoons, or cyclones are now getting impacted. So there's a new risk emerging in terms of location. So it's not just the intensity of these events. And there's also an increased expectation of science from stakeholders. So the expectations of us as a science community to deliver things that people need is increasing. So as the importance of the decisions increases, the expectations also increase. And unfortunately, we're not necessarily delivering on that in terms of climate risk management. So when you actually look at a lot of studies, they still only deal with mean changes, the average changes. So for example, again, this is a meta-analysis from the IPCC looking at food. and just looking at how climate changes are already impacting on crop yields across the globe, so wheat, soy, rice and maize, because they're the 4 biggest crops. And the importance of this was when we looked at that data, almost all of the studies only had changes in average yield. They didn't deal with the variability of that yield. So we're actually not delivering as a science community the sort of information that's needed in terms of managing climate risk. And another really big challenge is that our brains generally are not designed to deal with issues like climate change. So Dan Kahneman wrote some years in a book just recently, is that this quote, if you were to design a problem that our human minds are not equipped to deal with, it would be climate change, because it's distant, it's abstract, and it's contested, like people argue about it. And just to sort of tease apart those 3 things, why is it distant? Because often climate change is talked about being decades away, so it doesn't impact on people immediately. So people talk about the end of the century or 2050, not talking about tomorrow. But I would actually say, because of the changes that are occurring now, the impacts that climate change is already impacting on our systems, we need to talk about climate change as a clear and present danger. It's also distant in space, so people might talk about changes in Arctic sea ice or polar bears on ice floes and things like that. So it's really distant from where we are physically. So sitting here in Papua New Guinea, if you want to connect with people, talk about the changes that are happening in Papua New Guinea. And there's lots of them that are happening. It's abstract. So for starters, greenhouse gases are invisible. We can't see them. So we can't look there and see that, yes, the carbon dioxide concentration in this room has increased because we've got 150 people in here. But it has, but we can't see it. So our minds don't compute with this very easily. There is no reference point for most of these things. So for people, when they talk about a 2-degree change, Paris Agreement, 2 degrees means absolutely nothing to people. It's a really abstract concept. 2 degrees doesn't sound much. You know, the difference between a day that's 28 degrees or 30 degrees, they're both warm, they're both quite manageable. So 2 degrees is almost like irrelevant in most people's lived experience. They can easily cope with a 28-degree day or a 30-degree day. So 2 degrees is a really poor reference point. You have to relate it to the existing experience of people and saying, well, this is actually going to result in X number of really hot days where you can't go outside without suffering heat stress. And similarly, parts per million of carbon dioxide or methane or other greenhouse gases, people have no idea what that means. Is 410 good? Is it bad? Is it high? Is it low? And so there is no reference point. So we actually have to, when we're communicating with people, we need to put these reference points in so people can understand how things have changed. And also there's the argument that greenhouse gases are rare in the sense they're very small concentrations, 410 parts per million for carbon dioxide. If it's methane, it's parts per billion of methane. And so people think, oh, well, it's a small concentration, so it doesn't matter. But equally, we can actually talk about another narrative. So if you were talking about small concentrations of cyanide in your drinking water, it does matter. So it's not a small concentration argument, it's about what impact it has that should be the point of the discussion. And lastly, it's contested. So a lot of discussion about uncertainty. So, what's the variation? Have we really got climate change? Is it really happening? It's politicised, so we see a lot of arguments about climate change because different political perspectives about what should be done. It's conflictual, so it sets people or communities up against each other or nations up against each other. And it can be painful because some solutions cause losses as well as wins. And so there's always winners and losers when you come to political large-scale decisions. So climate change is a really difficult thing to engage people on for these sorts of reasons. And so we need to find ways of connecting with those minds. So it's not just about the numbers, it's not just about the analysis, it's about that connection. So one way, many years ago, that I worked with a colleague called Greg McKeon, and we came up with a way that you could actually connect management of short-term climate change variability using seasonal forecasts with long-term climate change. And it's a relatively simple concept, although fairly sort of revolutionary at the time, I guess, which was simply that if climate change resulted in increased frequency of El Nino or La Nina events or any other forecastable climate factor, sea surface temperatures in the warm pool in the Western Pacific or something like that, then linking management decisions to those could actually let you ride the wave of climate change. So if El Ninos became more frequent and you were a good manager of El Ninos, you would gradually become much better at managing that type of climate. So it's essentially an idea about riding the wave of change rather than ignoring it or resisting it. And of course, that idea is going to be much more effective if you have good seasonal climate forecasts, so more skillful, more timely, more appropriate forecasts. Now, one of the really obvious things to forecast is heat stress. So if we look around the globe, there's already various warning systems for heat stress, and so using various numerical prediction models to project a few days ahead when heat stress is likely to occur. And that's really important. We've seen just this year massive issues about heat stress across the Asia area, into Europe and also in the US because of serious climate events there. For example, I was just talking yesterday with colleagues from Korea, and they were saying how hot it's been in Korea and heat wave conditions. But this graph on the right-hand side, down the bottom, is a study which just came out last year, which looked at the incidence of deadly heat stress events, that's their terminology, going out into the future. So this is a scenario with at 2100, end of the century, with high emission scenarios. And you can see that right across the equatorial and subtropical belts, that heat stress is going to become really, really significant. So it's already significant in many places, but it's going to become more so. And their analysis was that by the end of the century, under this scenario, 75% of the world's population would have 20 or more days of heat stress in a given year. So heat stress is a really emerging issue, and one that is forecastable. So we can actually generate technical forecasts for this. But it's not just about the forecasts, it's just not about the technology, it's actually about how you connect technology with action. So a forecast by itself is pretty useless, but a forecast with an action plan can actually be really useful. So if you actually look at these sorts of action plans, and there's various ones available, essentially these are the key points about an action plan. For starters, you have to inform and educate people and empower people to make good decisions when there's heat stress coming, when it's going to be a really hot period. You need to think about community partnerships and action options so people can do something. So a really simple one, if there's a really big heat stress event coming along, you go and talk to your neighbour and you make sure they're prepared. If they're an elderly neighbour, run a bath of water or something like that so they can cool down easily in their own home. If that stress has gone on for a couple of days, go back, make sure they've got enough drinking water, make sure their house is as cool as possible. Really simple things, but they really do make a difference. So community mobilisation and caring for each other is a really important part of any action plan. It's not just about the technology. There's also policies and plans that support those sorts of activities, thinking about your healthcare system and making sure that the healthcare practitioners, like the doctors and nurses and ambulance systems and similar things, are equipped for those sorts of events. And also the last point is evaluation. So if you have an action plan, evaluate it. Make sure that it's actually the right action plan, or if you've had an event and it seems not to be working, change it. And then go through this whole process again of re-education, etc. So the emphasis there is actually about starting to think about the social and the institutional aspects of this. But what we actually see often within the science community, and particularly the funding of the science community, is quite the opposite. The standard narrative, the standard story, is what we call a climate-centric approach. And so that is, you put this big bubble of climate change or climate variability in the middle, and you hang off these sort of application sectors around that, applications in terms of water or biodiversity or food security. And that's where most of the money flows. So most of the money will go into that big bubble in the middle on climate change, and very little will actually go to the applications and the delivery, and even smaller amounts go to the psychology and social science of that delivery. And the problem with this is that's what we call the linear model, which we also call the knowledge injection or knowledge deficit model. And we actually know that this doesn't work. So these are just a couple of pictures just to sort of give a very simple idea. But it's the idea that us as a science community can load all of our knowledge into like a hypodermic, go up to someone, stick it in their brain, press the trigger, and have that knowledge absorbed by that person and usable by that person is ridiculous. It simply does not work. The knowledge injection model, you go once along to a policy group and talk about climate change and risk management, and that they're going to adopt that knowledge and be able to implement, it doesn't work. It has to be a relationship. It has to be a continuing analysis of what are the needs of those groups. And as a group, researchers, particularly climate researchers, actually have a really poor understanding of stakeholder needs. They might have some conceptualisation, but usually it's wrong. So we actually did a study, this is with Miriam Dunn a couple of years ago, and when we went out and asked people what they really wanted from climate science and what they were getting from climate science, or what they thought climate scientists thought that they wanted, all of these things were really, really telling. And so, for example, only a quarter of the farmers in this particular survey said that the global climate models about climate change were actually delivering what they wanted. And 3/4 said that the type of information they wanted was completely different from the type of information they were getting. So if we're to actually deliver climate science that makes a difference, we have to understand our stakeholders' needs. So it's about putting the decisions and values and aspirations of stakeholders in the middle of this diagram, and then the climate and the water and the food security are sitting around those. They're particular sectors which those aspirations and those values relate to. And so it's a completely different conceptual model of actually how to make this relevant, how to move from knowledge into action. And one way of doing this is participatory action research. So action research has been around since the 1940s. It was developed because there was a lot of voices in the communities which weren't being heard, and there was lots of knowledge which wasn't being used through the traditional knowledge injection, knowledge deficit models. And so there's many different flavours of this and different names given to it, but they're all fairly similar. And the fundamental characteristic of this is involving stakeholders in generating and using that science. So seeing stakeholders part of the research team, not as additional to the research team. And if you do this well, you actually can generate much more relevant, credible and legitimate knowledge. Legitimate means that it's generated through appropriate processes that people trust. It also increases the pool of knowledge and the resources available. So, for example, I work in food security and I have some knowledge about how climate change impacts on agriculture, but the knowledge that I have is just a very small part of the knowledge that a farmer needs to run a farm effectively. They have the majority of the knowledge in terms of climate and food security. I've got a little slice of it, a very specific, maybe useful slice. And if you think that that's the important part of it, then you won't be relevant and they won't talk with you and they won't trust you. But if you acknowledge and respect their knowledge and you put that together, then what you've actually got is an enhanced ability to respond. And the key difference between traditional activities in terms of science and participatory activities is the attitude of the researchers. It's not the stakeholders and their preparedness to engage, it's usually the attitudes of the science community. And if you acknowledge that the stakeholders and their problems and their opportunities are the core of your research, then all of a sudden you change the conversation. And so you actually, if you acknowledge that they're the primary reason that you're doing research, then you can actually have a really constructive conversation. And it's when you start to do this, it's actually about the process is really, again, starting to identify the values and the stakeholders' goals and the climate-related decisions before you talk about a climate solution, before you talk about this particular global climate model or this particular climate index. And when you're doing this, our experience is that you always start with the past and the present, because that's known territory, before you go into the future, which is unknown territory. And if you can actually establish trust that you know something that's relevant to them about the past and the present, they may trust you to go into a journey into the future. But if you start just with the future, that is a complete black box, that is an unknown to them. The future is a foreign land, and they won't want to go there. So it's about thinking about the process and the sequencing of introduction of different information. And as you do this, it's really important, in our experience, to be very clear about what the public values of your research are. So when we talk about public values of research, it's the underlying rationale that you're doing this. We're doing this research to improve development opportunities here in PNG. We're doing this research to improve food security in Asia Pacific. We're doing this research to enhance water delivery in a particular place. Those are the public values. The science values are about doing robust research, publications in journals, being able to engage with colleagues on a sort of an equal basis. And if you actually choose public values as your primary driver, then you're going to be engaging in meaningful research to a much greater extent. But you have to do that consistently as you go through project design and implementation. And in thinking about that, it's again not so much about the hard science, but it's actually about the social aspects and the psychology. So again, right across the board, what we find is that the social and psychological, cultural and institutional aspects are really critical in terms of motivation for people to take action, their capacity to take action, and the intentions of taking action and where they want to get to. So if you exclude those social and psychological factors, it's very hard to actually get people to move and move effectively. So we need to think very strongly about the social sciences and their contribution to things like managing climate risk and climate change. There's also a whole range of barriers and limits to action which need to be recognised and managed. And when we're dealing with that, often it's really important to talk about an adaptation journey, how the story of how people change and how communities change, how businesses change. And when you do that, what you actually find is that at the start of engaging with people in that story, people firstly focus on the technical. Oh, I'm going to change my dam rules, my dam water release rules, or I'm going to change this variety in my cropping system or something like that. But where they actually end up, as recognising most important, is actually in good strategic decision making. So it's not so much about the technical and the tactical, it's actually about the strategic and the values-driven decision making that's important. And so when we're thinking about capacity building, it's actually about not so much the technical, but it's actually about the strategic. And so you build that strategic capacity to make good decisions. And in doing that, often it's about developing leadership and leadership in those groups that we work with. And leadership, in my experience, can come from anywhere and from anyone. It's not about the top of the organisation or the Prime Minister. It can actually come from anywhere in our society. And we need to value that leadership and respect that leadership and honour that leadership when people have tried that, because it doesn't always work. But it's often done with good intent. And as I mentioned before, it's not so much about the technical, but it's about the story that you can tell about change and how you can participate in that change. Now, one of the warnings that I'd have about focusing too strongly just on seasonal climate forecasts and similar management of climate variability is that almost always that's used to manage and fine-tune existing systems. So if you've got an existing farming system, it's about fine-tuning that to improve the profitability or to reduce the risk. If you've got an existing transport system, it's about how to fine-tune that transport system so it can handle a little bit more rainfall intensity or something like that. But that actually, if you leave that too long, that can lock you in to that existing system at the cost of exploring alternatives. And so that can lead in maladaptation to climate change and sometimes in missed opportunities, because you're fixated on fixing up your existing system rather than saying, hey, there's a much better option over here. So as we move into climate change, I think increasingly we'll need to focus on systematic change or systemic change or transformational change. So systemic change is where you're changing parts of your system. Transformational change is where you're changing most of your system. So different goals, different sets of activities. So seasonal forecasts and similar things are really good on the left-hand side, the incremental change, but not really great on the transformational change. So a real simple diagram of this is that as we go from sort of existing climate change to future climate change, we need to think more and more about transformational change. And that means we need to think, at least initially, we can think about technology and dollars and physical change. But as we go into those biggest types of change, we need to think much more about the institutional and social, psychological and cultural aspects of change. And the things that we deal with now, the tools that we deal with now, the seasonal climate forecasts and similar things, are suited to the left-hand side of that diagram, not necessarily the right. So we need to think about how does our science need to adapt and how does our science need to change as climate change progresses. So a really quick summary of just what I've been talking about is climate changes are already happening. There's a very, very strong signal of human influence there. So we're down to the 99.999% level now in terms of human influence on climate change. I would actually say that seasonal climate forecasts and similar things, such as the APEC climate centres worked on in the past, they do have a role in adaptation to climate change. So that's particularly about managing the ups and downs and riding with the wave of change that we're likely to see. But any of those forecasts, whether it's seasonal forecasts or heat wave forecasts or similar things, they're useless or nearly useless unless they integrate it into an action plan. And the action plan is where a lot of the challenge lies and a lot of the effort lies in terms of getting change happening. There's ways to actually approach that and make that easier, like action research approaches, participatory approaches, and the social science can actually help with that translation of hard science into action. And we need to be very inclusive of social science in doing that. And just to repeat that warning I said before, is that if we have an over-reliance on seasonal climate forecasts, that can lock us into the way things are rather than the way things could be. And in the end, it's the way things could be that is visionary and drives the larger scale change that we're likely to see over the next decades. So we need to think clearly about the limitations of the technologies that we're using and thinking about whether they're suitable for the purpose that we want. And lastly, we really do need to put a lot of effort into building capacity. We need that in all countries across the globe, developed and developing. And critically, that's about developing capacity for strategic and proactive decision making so that we actually start to become on the front foot in terms of climate change rather than perpetually on the back foot.